Right. Earlier, we learned the routing protocol, RIP, routing information protocol. Dynamic routing protocols helps to discover the destinations which are far away. The advantage of dynamic routing protocol is you no need to know, there's no need to know the complete topology. All that we need to do is we need to enable a routing protocol and advertise the connected networks. That's all. Or enable the protocol to run for that connected network. And the protocol will take care of distributing the routes. This is how routes are learned. Learning routes like this is much faster than reconfiguring on every router. Not only that, the convergence is going to be faster. Whenever there is a change in the network, the change will be notified very fast. These are all the advantages. The disadvantages in a large network, when routing protocol decides a route, we will not have control over the path selection because the routing protocol is the one which decides the route. The path selection is as per the metric. Every routing protocol has got different ways to measure and pick best routes. So, for knowing what path might have taken, need some verifications, like you need to trace route and see, or you need to know what routing protocol is enabled so that you will know what behavior, how it picks a path. And then only you can have some idea in path selection. Whereas in static route, you write the route and you know the packet path taken. So we learned all these things in our past. We also learned the protocol OSPF. Now we are in this protocol RIP. The difference between OSPF and RIP is very big. RIP is a distance vector protocol. OSPF is link state routing protocol. OSPF, based on the link state advertisement, the link state database is built, and only the link state database gets distributed among the neighbors, using which SPF algorithm picks one best path with a low cost and install the best path or recommend the best path to the routing table. Whereas in BGP, they rely on advertisements. The routes are advertised by every router. All those routes that are available in the routing table are advertised to the neighbor along with the hop count. Along with the hop count to the neighbor, not their own neighbor, their own hop count. For example, this 10 network, when router A advertises, it will say for you it is one hop. So who calculates the metric? A calculates on behalf of B, and B learns it, and B advertises to C saying for you means actually it is not talking to C. As we saw earlier, it is advertising to a broadcast address saying whosoever receives this, for them it's to hop. So router C or router B, they don't do any sort of smart calculation to decide their own metric. They simply learn whatever the neighbor gives. This is how the distance vector protocol learns route. So now router C says, in order to reach 10 network, I need to go this direction and 2 hop away the destination will be. The distance and the direction. That is why it is distance vector protocol. RIP is a distance vector protocol. The distance vector protocol, they all learn routes through rumor. Router B is advertising with 2 hop. What if router B advertises with 12 hop? Can router C says no, you're telling lie? It's supposed to be 2. How can you give 12? No. Router C has got no clue that router B is spoofing. Router B is giving a wrong info. Router C has got no clue. It cannot find if router B gives some wrong information. Instead of 2 hop, if I go to B and configure, we call it as offset list. If I configure offset list, using which I can tune, I can give different hop count rather than the original one. When I do that, using offset list, when I go and change the hop count to something else other than the real one, see, I have to believe that I can do that. See, instead of saying 2 hop, I can make router B to say 12 hop to reach 1010 network. To reach 10 network, 12 hops. Is it true? No, it's not. But C will believe. In routing table of C, you will see 10 is 12 hop. This is what we call it as learning by rumor. Okay. Now today we are going to do the lab. Let's quickly revise a few more things that we learned. Then we'll get into the lab. The other things that we saw earlier about RIP is RIP uses periodically updates to inform others about the networks, and if there is any change, the update will stop coming for that particular network that went down. So the routers that have already learned the route, they will wait for 180 seconds, which means 3 minutes, hoping at any moment the update will come. But if the network is really down, there's no chance of update coming. So the router which is waiting for 180 seconds will advertise that network information to the downstream with a hop count of 16. That makes all the downstream routers to know that the network is possibly down. We need to remove the root. Yes, they put it in possibly down state and remove the root in 60 seconds. So totally, after that network failure, it took 240 seconds for all the routers to flush it out from the routing table. The root information to get flushed out, it takes 240 seconds, 4 minutes. All right. We call this route poisoning. And we also learned that there is something called split horizon, which is on every port. I'll show you even before enabling RAPE. So these routers don't have any protocol. Maybe some static routes may be there. Show IP route. Yeah, there are some static routes you see there, 10 and 20. Show IP protocol is the command which we use to check whether we have some routing protocol. There is no routing protocol enabled. I would like to show you show interface F00. Not interface, show IP interfaces. Not S will not come. IP. And you can see split horizon is enabled. So even before enabling RIP, I'm showing you split horizon is enabled. This prevents advertising the learned network via the same port. In turn, you prevent loop. Split horizon is good, but when a network is found possibly down after waiting 180 seconds, the network with metric of 16 will be flooded on all direction, including the upstream. Usually, updates won't be going to upstream because of split horizon. What is upstream? The direction via which you learned the network is an upstream. What is downstream? The direction to which you give the update. So the direction to which you gave the update is downstream. That direction, when an update goes with metric of 16, which is an infinite metric for a RAPE, we call that as route poisoning. When it goes in the upstream direction with a metric of 16, we call it as poison reverse. These are the only two difficult terminologies in RAPE. What is poison reverse and what is route poisoning? Let me repeat with a diagram. About this 10 network, advertisement enters on this port F00. This router has learned it, and this router has also advertised it. So router C has learned it via this port. Now, when this network goes down, say for example the link got cut here, the network goes down. Router A will stop advertising about the 10 network. Router B waits for 180 seconds. After that, in both the direction. This is downstream direction. This is upstream direction. It says 10,000, hop count 16. Going in this direction is called as route poisoning. Going the upstream direction from where the actual update came, which is not possible when the update is live. Right now, the network is dead. After 180 seconds, it overrides the split horizon rule and goes back and cross check once again with 16 hop. We call it as poison reverse. Reverse. Because it goes reverse direction, which is not usual. Only in this situation, the update goes reverse. In case if this is alive when this update goes, RA will not accept it because RA will say, hey, it's directly connected network. It's my network. It is directly connected network and it is just zero administrative distance. But what you are giving is 120. RIP administrative distance is 120. So router A won't accept RIP's update in first place because router A says, I don't need your update because I got directly connected. 10 network is directly connected. Router A is not going to accept if update comes when router A having network. So for some reason he stopped sending about 10 network. Assume this may happen. So poison reverse won't cause any confusion. Right. So let's now go and see. Did I miss anything? Okay, version 1 and 2 differences we'll see later, which we saw earlier a little bit. We'll see again later. Let us do a small lab. I'll go and remove these static routes first from all these three routers. Then I will take it to rip, show, run. So this is the static default route I already got. I'm going to remove this. Done. So we don't have any static routes, and if I'll ping from left to right or right to left, the ping won't go. The reachability won't be there. Ping 20001. See? Immediately I'm getting a message from router A's address. This is router A10 255.255.224 is router A address saying the destination that you're trying to reach is unreachable. Router A don't have route, that's why you got this. To enable REAP, I no need to know the topology as I said earlier. All that I need to know is my own directly connected. So router A knows that I'm connected to 30 and 10. That's all router A administrator needs to know. The router B's administrator should know that they got 40 on one interface and 30 on another interface. Likewise, router C, router's administrator, should know that they got 20 and 40. That's all they need to know. So these three administrators need to go and advertise these networks using RIP. This advertisement will make the others to learn. Let's see how to do that. I'm going to router A. In the global configuration mode, you say router RIP. And the two networks that we have here is 10 network. Network is the keyword. Again, network 10 and 30, right? 30. That's all. Let me show you now, show IP protocol. You see, protocol that you're running is RIP. Every 30 seconds, it's going to send update. It will consider a route to be invalid after 180 seconds. That's also called as hold time. And it will remove the routes from the routing table only after 240 seconds. The current version that we are running is version 1, but surprise, version 1 can receive update even from version 2. But sending update is only version 1 update. Receiving update can be received from the neighbor, both version 1 and version 2. But because I'm using the word neighbor, you should not think that RIP will form neighbor. No, they don't form neighbor. Neighbors are not discovered because there is no hello packets in RIP to discover neighbor. Without knowing to whom I'm sending, every router will send update. In case if you have equal cost path, meaning for a destination you have multiple paths with same hop count, they are considered as equal cost path, and up to 4 maximum path can be used. Up to 4 paths can be used in the routing table to load balance. Currently, RIP is running on this router for these two networks. You remember, those are the two connected networks. So far, no gateway is discovered, meaning there is no neighbor router found. Means there is no update, no RIP packet coming from any other router nearby. As I said, the administrative distance of RIP is 120. So when you run RIP and OSPF, you run RIP on this 3 router, you also run OSPF on 3 router. OSPF is 110. So RIP routes will not be entertained. RIP routes will be ignored because administrative distance lower is better. but you can go and change it if you wish to. Right, I'll show you how to change that. Now you see router RIP. If you want the RIP to be preferred over any other routing protocol, then I need to say distance. The lowest administrative distance is for EIGRP, which is 90. So if I'll say something lower than that, like 89, this router, only this router, not every other router, only this router, this locally significant number, only this router will prefer RIP, not EIGRP. See, the original administrative distance is 120, but I have changed it to 89. You see here, the original was 120, but now I have changed it into 89. Again, I'm telling you it is locally significant. For this router to choose whether RIP route or WSPF route or EIGRP route, this number will be used. The protocol with the small number will be preferred. The routes given by the protocol with a small number will be preferred. Okay, now what I'm going to do is I'm going to remove the distance. That's all. If you remove this, it will come back to default. You don't need to say 120. Look at this. Just come back to the original. Likewise, I'm going to go to the other two routers to enable RIP. Someone tell me what are the networks that this router got. What are the networks that this router has got? You can see here it's 30 and 40 alone. I think you are in mute, that's why I'm not able to hear you. Router RIP network 30, network 40. Repeat the same thing on other router, not the same number, same configuration, but other networks. What are the networks here? 40 and 20. You can also see in routing table 40 and 20. Router RIP, the connected networks are 40 and 20. Now we finished configuring the protocol RIP. The version is default version 1. We learned that version 1 will send and receive the updates through multicast. I would like to show you that. Debug IP RIP. This is not the usual command. This command we don't use in production because this command will consume a lot of buffer. So when RIP sends and receives update every 30 seconds, see, what does it says? It says I'm sending version 1 update to to broadcast address, and it is advertising the 20 network with metric of 1. That is right. RC has got F00 with 20 network, so it is advertising to a broadcast address via F01 where RB is. So if you go to RB, show IP route, you will see 20 network with 1 hop. And RB will advertise to A saying 20 is 2 hop. So when I go to router A and check route, show IP route, it says 2 hop. That 120 is the administrative distance. That's the format. The destination network in the bracket 120 administrative distance slash the hop count via the gateway address 30002, which is router B. To reach that, the interface need to take is F01. Now if I show IP protocol, you can see the gateway address. This is the neighbor's address. This is not a learning neighbor. This is simply to say I learned updates from these addresses. In our topology, it's only one address possible for router A, but for router B, there will be two addresses possible because it has got two different source from where the updates are coming. Check it, show IP protocol. You see, this is router A and this is router B address. And let me go and stop the debug, otherwise it will keep on consuming the buffer. You all means what? Undebug all. This is what means I'm saying stop the debugs. I don't want to see the debugs anymore. Meaning these things won't come hereafter because they take a lot of buffer memory. Alright, so if you want to see, this is the command debug IP. If it is for RIP, you need to say RIP. If it is for OSPF, you need to say OSPF. If it is for EIGRP, say EIGRP. Now I was telling you every 30 seconds the update will come. I can show you that in the routing table. Show IP route. Look at this timer here. 14 second, 18 second, 10, 20, 21. Watch the timer closer. 24, 26, 27, 28, 0. See? So which means a fresh update has come. That's why it is resetted to 0. Every 30-second update is coming. You see again. 10, 12, 13, 14, 16, 17, 18, 21, 24. See, 0. Which means updates are coming. Every 30 seconds, the updates are coming. All right. So any questions on what we have seen in this demo? See, for the console, you're seeing this running configuration. For the console, you have DRAM, dynamic RAM. This all comes into your display through the DRAM. So you are just provoking a protocol to show those things that are going behind. Those things don't come into DRAM usually. See, do you see every 30 seconds any update going now? No. But when you put debug IP RIP, you are telling all the RIP related conversations which are going behind the screen needs to come to the display, needs to come to DRAM so that it will be displayed. Any other question? All right, so we'll continue this in a